Space Club started our webinar series for 3 years, since of 3 years. In May 2020, we started our webinar series when all our other activities were struck due to the COVID pandemic issues. We weren't able to conduct our camps, our project presentations, anything. So at that time, under the leadership of Kutu sir, we started the webinar series, and today we are on the 59th session of webinar series. For the past session, we had experts from ISRO, DRDO, IITs, NITs, ICERs, and experts from other premier institutions also, global universities also. So today I'm so happy to welcome all of you to the topic Engineering for Space by Dr. Tapan Misra, who was a former director of Satellite Application Center, ISRO, Ahamedabad. So we are very happy to welcome to our program, sir. And I welcome all other experts from ISRO who have joined here, ISRO veterans, Bhatt sir, Padmanabhan sir, and all other ISRO veterans, including our mentors, Jairam sir, Kutu sir. I welcome all of them to this session. And the student participants and the teachers and the parents who are joined for this session, I welcome all of them to this session. And for about today's session, we have few instructions for the participants. All participants are requested to switch off their camera and mic when they are not speaking. At the question answer session time, after the speaker's talk, we will have the question answer session time. At that time, if you want to ask any questions, at that time only you can switch on your mic and camera. Otherwise, please turn it off. Otherwise, it will be an interruption to our stream. Our session is streamed in YouTube, live streamed in YouTube, UL Space Club YouTube channel. So it will be an interruption to our streaming. So please don't try to do that. And we have a chat window here. If you are not able to ask the question directly, you can use the chat window. You can type your questions in the chat window, and our student coordinators will select the questions for the question answer session from the chat window, and they will ask it to our speaker. So once again, I am very happy to welcome all of you, UL Space Club, all of you to the UL Space Club webinar session on this wonderful occasion. And once again, I especially welcome our chief guest, Dr. Tapan Misra, and I would like to welcome Shadil sir to give a detailed introduction about our speaker. Shadil sir, over to you. Okay, sir. In that time, I would like to announce that our UL Space Club webinar series are always followed by a quiz related to the particular topic of each session. Today also, we will have a quiz related to engineering for space. Our team coordinator, webinar team coordinator, has prepared few questions, and they will set a quiz in Google Forms after this session. So you can access the Google Form quiz after the what of times of this session. So I request all students to attend the quiz and try to give your best for the quiz competition. Thank you, sir. And I welcome Shadil sir. Shadil sir, are you ready? UL Space Club started our webinar series for 3 years, since of 3 years. In May 2020, we started our webinar.
So some hindrance you are.
ആരൊക്കെയാന്ന് അറിയാം. നമ്മളെ സ്കൂളിന്റെ അതിലാ വരും. കുട്ടികള് ഹോസ്റ്റലേഴ്സ്.
Yes.
Good afternoon.
Good afternoon. Distinguished guests, colleagues, dear students. Let me begin by expressing my gratitude to the UL Space Club personnel for choosing our institution co-host the 59th edition of the monthly webinar. It's a great honor to us. 𝗬𝗪𝗏 Higher Secondary School was established as a secondary school in 1948 by a group of social reformers. In 1991, it was elevated to higher secondary, currently celebrating its Diamond Jubilee. Our school is one of the oldest higher secondary schools. Thousands of people completed their studies from this school during this long period. I would like to take this opportunity to proudly share that a lot of our former students have made remarkable academic achievements that have been recognized by the scientific community. The most recent name on that list is Dr. 𝗏𝗏𝗏𝗏, who received a US patent 2 months ago for research on gallium nitride chips. He is currently a postdoctoral researcher in Stanford University. His development is indispensable component for the transition from 4G to 5G and 6G. This was said in an effort to motivate my cherished friends, and I know that one day I will be delighted to hear about your extraordinary accomplishments. I am confident that you may start your path to tremendous achievements with the help of this webinar. Yes, students, this is your chance to grab the attention of the nation's leading academicians. This is your time to overcome your nervousness and offer your views and questions. You have the opportunity to start building your confidence now. Be wise with it. Good luck. Thank you everyone once again.
Thank you, Nishida ma'am, for your introduction to this as a co-host of our program, and you join here with your teachers and students and other students here, and it's a time to introduce our chief guest here, Dr. Tapan Misra. As already mentioned, he is an architect of our ISRO, the greatest organization in India. Tapan Misra has been the director of Space Application Center and the Physical Research Laboratory in ISRO. He later became the senior advisor to the chairman ISRO. Presently, he is holding the position of founding director and chief scientist of a startup named 𝗚𝗟𝗨𝗕 Limited based out Calcutta. He is widely known for his design and development of C-band synthetic aperture radar (SAR) of RISAT-1. He steered the development of RISAT-2 series of high-resolution X-band SAR systems. He conceptualized and led the development of highly miniaturized dual-frequency L and S band SAR DFSIR of Chandrayaan-2 orbit. He is also the principal architect of novel SEEP-SAR of NASA ISRO SAR, likely to be launched in 2023. We are eagerly waiting for that, sir. He received numerous awards. Notable among them were Vikram Sarabhai Research Award in 2004 and the ISRO Merit Award in 2008 for his contribution to the development of SAR technology. He is a fellow of Indian National Academy of Engineering, a corresponding member of International Academy of Astronautics, and a fellow of IETE and ISRS. He was awarded as DSc Honors in 2016 and the Distinguished Alumnus Award by 2017 by his alma mater, 𝗪𝗪𝗕𝗓 University. He chaired CGMS in 2018, Coordination Group of Meteorological Satellites, and represented India as a principal to the CEO's Committee on Earth Observation Satellites in Paris in 2017, and participated as a team member of Indo-US Strategic Dialogue on Space Cooperation in Washington, D.C. in 2016 and 2018. He is also taught at IIT Kharagpur, IIT Jodhpur, and adjunct professor. He holds 8 granted patents. He has 5 copyrights and more than 55 papers to his credit. So the greatest man has come to this forum for our students who are doing little bit more than spreading this knowledge. They are trying to make a payload of their own with the Higher Education Institute in Kerala. Then it would be a motivating session for this. And one more interesting thing is that this session won't be a presentation. As Tapan Misra sir, while accepting our invitation, he told us, I would speak only 15 minutes. After that, the student has the great chance to interact him directly. And I would think that the students will utilize this golden opportunity to sharpen their thoughts and activities in all these areas. We have a heterogeneous group that starts from the 6th grader Adil, and that would end with some research scholars here, along with the veteran scientists of India. We are proud to have these large group of veteran scientists and academicians and students in this forum, and that's a great enthusiasm for us, and that would be a motivating for us. And before our beginning of talk, our founder 𝗖𝗟𝗨𝗕𝗏 sir has to declare some more achievement of this great achievement of UL Space Club regarding its space tutorship. I welcome 𝗖𝗟𝗨𝗕 sir to declare that great event here. Welcome, sir.
Thank you, 𝗪𝗪𝗪𝗓. In fact, I didn't want to take time because I don't want to come between Dr. Tapan Misra and our eagerly awaiting students. Yet, as 𝗪𝗪𝗪𝗓 said, to say 2-3 things. Already Varun and 𝗪𝗪𝗪𝗓 have spoken about all important relevant things, and Principal Nishida Madam also did so. And I only wanted to say 2 things. One is that, we have been in this area of nurturing and developing and grooming students, and it has done lots of good for our students, I believe. And it has also received a recognition recently from ISRO as a space tutor. ISRO has recognized UL Space Club as a venue for space tutor. That we regard highly, and our students are excited about this fact. In fact, 4 students and 4 teachers were together 3 months back in Bangalore in ISRO headquarters, meeting the people, including our previous chairman, etc. And that has given them lots of enthusiasm and excitement. So that is one. Second is that we have been doing lots of after COVID has freed us from its clutches. We started our space camps as usual. We did in Trivandrum, we did in Kusat, we did recently in the University of Calicut. Now next camp is on the Moon Day. We are going to have it on 21st July in UL Cyber Park, Calicut. And amongst the students present here, we will be selecting a good number of them. And you have an opportunity to spend a full day in UL Cyber Park. And we are getting some veterans to interact with you. So these are the 2 things. I refrain from talking further. And I only wanted to say that today is a blessed day for us. Blessed with reference to today's webinar. We have been able to get Dr. Tapan Misra. Already he has been spoken about by 𝗪𝗪𝗪𝗓, and he is very highly well-known veteran, and most some it's about synthetic aperture radar reference was here. He is known to be a very famous person in microwave technology and space applications, remote sensing, computer communication, and things like that. So we are very blessed today to get you, sir, and we welcome you with all our hearts. And students are awaiting to interact with you and to learn a great deal from you, sir. And this will be a beginning. Kindly keep granting us these blessings again and again. Thank you, sir. Welcome.
Good afternoon, good day, sir, Sajid, and all the UL club members. And I see many of my seniors in ISRO, before whom I used to tremble in my time in ISRO. So they are there. So that feeling of trembling has not gone. They are still there. And the students who are participating in today's discussion, and you see that I am sitting around 2,500 kilometers from Calicut. That is in all the way in Calcutta. And it is surprising, we speak different languages. We are from different states. But we are joined by a very simple common thread, We all have the 46 chromosomes. Look at the human being, the nature, let's say all of us have a 46 chromosome, same 46 chromosome, the minor variants here and there made us American, somebody made us Indian, somebody made us Malayali, somebody made us Tamilian and all. You see that nature's all complex manifestations are actually from very simplicity. We are all, space enthusiasts, all the people here. If you just look at the space, you see that Newton's 3 laws, they appear so simple, and the space is governed by these Newton's 3 laws. I don't know, we send the satellites, very complicated satellites, they spend their life in space, they do a lot of jobs for us. But all of them follow the age-old Kepler's laws. And that's a huge energy source. What we have today, they follow Einstein's very simple law, E equal to mc square. And there's Newton's gravitational law or Coulomb's law. They're so simple. They do so much complex job in this universe. And the laws behind them is a very simple. Or you look at the universe, expanding as per the Hubble's law. What it says, the further you are, you will be moving at a more higher speed. That's all. And it will be represented in the red shift of the signal you receive from that. And the Hubble's law is so simple, it gave rise to from Big Bang theory and the universe, how the constellations will interact with each other and every other thing. So, wholesome. So that nature is very simple. The laws governing them are simple. But the manifestations and apparent manifestations, which we consider as complex, they are actually simple, and we must understand that. And when we go for the space technology, we must understand the space technology is not a rocket science. Let me be very clear that the space technology is not a rocket science, but all other rocket scientists present it as a very complicated science, because if you don't present it in a very complicated way, the government will not give the enough budget. That is the crux of the problem. And you will find one of the very, very important criteria of the success of space science or all the space technology, all the rockets built in Trivandrum or the satellites built in Bangalore and all the payloads built in Ahmedabad and all the data received in NRSA or the launch port in Shah or any other place and at the similar places all over the world. One thing is very important, they have to be reliable. You know, when you drive a car on the road, if it fails, you can get it repaired. But if a satellite fails, you cannot get it repaired. And that is where one important thing comes in that engineering, it should be reliable. And who are reliable? The reliable relations in life is a parents and children. You know, there is a pure love. There is nothing is there. The reliable technology are those which are very simple to use, simple to imagine, and simple to implement. And they are the most reliable. And you know, they say nobody on the earth or in the universe can be 100% reliable. I don't know whether the God himself is not fully reliable, how human being can be reliable. How even an engineer cannot be omniscient, cannot be knowing everything. But the hardware we build for space, you know, they have to be reliable. So the first criteria of the engineering in space, it has to be simple. You know, that's the first basic principle. In fact, those who forget those fundamental principles, they make the hardware complicated and many of them have failed. And when we fail, we understand that we have missed really the simplest of the things. So I'll give you small examples, a few examples, not all in my life, what I have seen. You know, that my first project was the airborne sir. Jairam sir knows all the trials, tribulations we went through. And in fact, the SAR, when we built it, you know, for aircraft, it actually failed 52 times. There were big reviews, the big discussions. And, you know, as usual, when there is a lot of failures, there is a lot of blame game also goes, you know. Scientists are no exception from the society. We are part of the society. We behave like the society. And, you know, finally, when we located the problem, it is a class 8 problem. You know, what is taught in class 8 physics, we have become so much big engineers, we forgot what our teachers taught in class 8, the coronal discharge. At a low pressure, the high power systems, they discharge electrical discharge, and that was only the cause of failure. And once we understood the very nature of failure, we repaired it in one day and the next flight was successful. And I'll give you another example, you know, that we have made, this time we have flown our, you know, NAVIC satellite with our own atomic clock. It's a very, very pride of that. In fact, when I took charge of a SAT, automatically the atomic clock development also started and it came under my ambit. And to my surprise, you know, I was told that the atomic clock is so difficult. You know, that's in fact, we have been importing this atomic clock from abroad, and many of them were failing. And whatever for internal development, you know, we are importing from, I think, some other Ukraine or some other country. And everybody told that rubidium bulb is a extremely complex development. And you know, I happened to meet, by the invitation of government of Israel, to one atomic clock factory in Jerusalem. this is, and to my surprise, that the whole this so world famous factory is situated in a 3-bedroom bunk flat, and there is only one clean place, that was a glove box, and in that glove box they were actually getting which is the cleanest facility, 100 class 100 we call them. I don't want to make it complicated. That is a small glove box at the size of my table, and in that glove box they are heating it to 85 degrees. That was the vapor point of rubidium, and that the saturated rubidium vapor, and they put a test tube like thing, and they have put a it's a knife like thing. So it is a scissor like thing heated at 800 degrees. That was simply cutting this test tubes in pieces and sealing them instantaneously, and that filled out the rubidium vapor, and they were the so complex rubidium bulb we have been importing at a cost I cannot tell you now. And I got it implemented, and I simply discarded the big buildings, and we got our rubidium clock. Now, everybody tells you that a rubidium atomic, see that the art of selling is making the product appear to be very complex. And if you hear the salesman, you will first lose your confidence in building it, and you will end up paying the high price, and that is what we Indians do. So I was, in fact, when I took over, I found our insect communication system. We are, importing waveguides at a very exorbitant cost. The space qualified waveguides. And the waveguides are, it is like you have seen the water pipes, that they have a cylindrical, circular cross section. You assume this is a metal pipe with a rectangular cross section or a square cross section. That's all, nothing great. But then, to get a 90-degree bend, to get an S bend, it appeared to be so complex. And everybody said, in fact, they've been in SAC importing for more than 30 years. For all insect programs, and the cost, we have to give order. They will manufacture and send, that the government process, placing an order is a 6 months job. The fellow will deliver in another 1 year. So 1.5 years will go from your design to when you get it. I asked the people, why it is so difficult to build waveguides? And to some young engineers came, that they found one material, it's very cheaply available. It's called a cerobond. And this bond material is a metallic alloy. Its melting point is 80 degrees. And if you melt it in hot water and boiling water, and then pour it in the waveguide, and then pull it, and the whole waveguide gets filled up with this alloy. It is a very soft alloy. And once it is filled up with a soft alloy, you can build waveguides like anything. And we actually, I don't know how much money we saved for the government, which we have built a full facility at a very, and hardly a few lakh rupees to mass production of waveguides. And for last 10 years, you will see that all the waveguides being thrown in our communication satellites, they are actually made in a very, very simple way. And the cerobond is a reusable metal alloy. And once I did another effect, let's say, what happens when you become expert, like you called me an aperture, a synthetic aperture expert. Actually, nobody is expert, I realized in a hard way, every time I build a system, I learned many newer things. We have built one is 6-meter resolution synthetic aperture radar in the airborne in C-band, and we did not use we could process the data without a stabilization system with the antenna. And because the SAR has a very funny principle, to get the best image, you have to look 90 degrees to the flight direction. And because the aircraft, it meanders and all, so from compared to the flight direction, you have to have a stabilization system. It will continuously rotate the antenna so that it is always perfect. It will look perpendicular to the flight direction. And we processed it with a 6-meter resolution, and we felt confident, and our algorithm could process it without a stabilization system. If you buy anybody's synthetic aperture radar, it will have a stabilization system. But we did not have that, and then we operated and we got nice images. 𝗟𝗪𝗦𝗢 sir knows all these histories. So the next SAR have to build. So we simply hiked our expectations. We said no more 6-meter. We will build an airborne synthetic aperture radar and with a 1-meter resolution. And we were very confident because I was also having the pride. Everybody was calling me a synthetic aperture expert, radar expert, and inviting me in many places like you invited today. And we said nothing doing, it can be processed so easy and all. And to our surprise, when we went to process, the image pixel, instead of a circular, it became like a balloon. If I get a good resolution in flight direction, other times I get a very bad resolution, and vice versa. It is as if the image pixel is like a balloon. I press in one direction, and other direction it goes. And it took for me almost a month, almost a 24-hour job, and I got almost mad. And I thought I must leave this place before my reputation goes off in ISRO. So let this burden be passed to somebody else. Because when you are frustrated, you think like, criminals, how to pass the burden to somebody else. But then I stuck to it. Finally, I realized that I made a mistake. That what everybody else does, making a stabilization system to orient the antenna so that it looks perpendicular to the flight direction. And my ego was hurt. If I go that I want to build, I need one more stabilization system. I have become full and all of that. And 𝗟𝗪𝗦𝗢 sir will do a very controlled smile, and because he was the person who used to keep the budgets and all. So I thought that would be below my dignity, and ended up in writing a software. Why should I rotate the antenna? I can mathematically rotate the track and process that data. In fact, it has become a part of very significant contribution in SAR technology. That it was I learned very hard way. Never call yourself an expert. You call yourself a student, because every day, every morning I get up, I learned something new which I never knew in last 40 years. That is all I can say. I have another very interesting thing that we are doing that MSMR payload in 1999, and we have an elaborate QA system, and it's a payload. You need a thermal enclosure. So it's like if you are cold, you need a sweater, and if you are in a hot, then also you still need a thick garment. So that is what exactly the space they do. to prevent the payload from getting heated up or cold, because it goes through extreme temperature environment. So they needed envelope of a cover, and we put a metal envelope on which all the thermal blankets. And metal envelope had a heater, in place is cool down. But there were 6 such microwave subsystems inside, and the moment you put metal envelope, the small leakages of the subsystems, they were coming out and getting absorbed by, each subsystem was getting corrupted by other type. That was the situation, And it was a maddening situation, and finally we got a solution. Say, we have to maintain thermal enclosure. Enclosure means it's like a thin aluminum sheet. It's a bend like a box around the payload. And what our all experts they told, that they will put inside, will paste this absorber on this aluminum. It's very nice. ISRO had a lot of experts putting all absorbers and everything, and these are very thin sheets, a rubberized microwave absorbers, which are put, and its success was fine, and it has gone through all thermobag tests, and it went to 𝗖𝗟𝗨, and I was the person responsible for integrating the payload on the satellite. And I was slightly curious, how is this absorber bonding on the metal plate? Because it has gone through all the certifications, everybody certified. This bonding adhesive was very good. And I just peeled off one corner, I found it was coming up. And I started peeling off further, and it started. And finally I peeled off the full absorber. And to my surprise, that all of ISRO, including me, did not understand the basic fundamental of adhesive bonding. The surfaces you want to bond, they have to be made rough. At least one of the surfaces have to be made rough. And we had a very, tinned aluminum sheet. It was a very smooth like mirror. On that we put the absorber and adhesive. And then when we started peeling off, it all started coming out. It could not have withstood the environment. And everybody thought, there's a Tapan Misra is a lunatic. He has he just deliberately spoiled that payload, brought everything. I did not listen to anybody. A lot of experts were there. I listened to it. Somehow my hunch was telling me there is something wrong we have done, or we have to make the surface rough. So there was a 2 technical assistants with me. They are no more. They are on Earth. I told them, you take hacksaw. One hacksaw blade, it should go in one diagonal side, and another will go for another diagonal side. And they'll make the surface rough. We bonded, and it did not come out till, and it went to space. It functioned very nicely. Nothing happened. Now the solution was very simple, and the method was very simple. If I look back, it didn't need much of a brain, but at that moment, when we were so much proud of our own expertise, our own conviction on ourselves, we forget the very simplest of the sciences and make things complicated for ourselves. I'll give you one example. I hope ISRO doesn't beat me up. We are making the 𝗪𝗪𝗕-3, the second payload. And I was the director, the second of this, the second or third, 𝗪𝗪𝗕-3B or 3A. And it's a very high resolution satellite. It's around 0.5 meter and better than that. And I was sitting in the director's room and suddenly found an array of QA people and the optical designer, electronics team. They came and they were very anxious, and they were telling that they will not be able to meet the schedule. I said, what happened? They said that one of the detector, the adhesive bonding to the metal structure, it has come out. I said, oh, you put bonding. They said, no, this bonding will take curing. And to cure it, you have to actually open the complete structure and then access that place, cure it, and you put the adhesive, then they strap it, and then you do it. I said, then what should be the time schedule? They said, it will take almost a month to get back, and that all the schedules have to be told. There's a delay of schedules because everybody will escape. That the director will get all the banging from the chairman's office. This all our projections to PMO has got disturbed. Our there's a users will be suffering, and all this I have to hear, and I cannot pass the blame to others because it will not be good for leadership to pass the blame to others because I have to absorb everything. So I was figured out something. I said, you buy a quick fix. I said, quick fix? It is not allowed in space. I said, don't do that. You are still accessing the detector with a pincher, like a small. So you put in the corner small quick fix. It will dry in another 2 minutes. Now it is rigid. Then intermediate point, you inject the space qualified bonding. By the time in 24 hours, those bonding dries up. Even if this quick fix comes out, it's not an issue now. And this ISRO is just people of space qualified people. We have an adhesives of a tube costing 1,000 rupees per tube. But we didn't have that, I think around 30 rupees that tube we had. Somebody went and bought it, and then the detector, it was bonded as I suggested, and it went to the space. And nothing happened after that. It is working, and we could save 1 month, and we could save our chairman, ISRO, from big embarrassment from PMO. Because, in government, the stick comes from one after. Just don't be happy that you are beaten up by your senior, because your senior also will be beaten up by his senior. It is something, you see, the technology was simple. In every case, you will find that technology is very simple, and it is just because we did not, somehow we thought that we have to think very complicated. I'll give you last one example. The GISAT satellites, we have a lot of, actually ISRO planned, there's one GISAT satellite got lost. ISRO planned a GISAT satellite in geostationary orbit, that is at 36 kilometers, 36,000, and and we calculated, it needs a mirror. It's a parabolic mirror of 1.6, around 1.4 to 1.6 meter dia, and it has to be made from very costly zero-hour material. It's a special type of glass, and if you want to get a 1.6 meter zero-hour material, you have to actually get a glass blank, zero-hour glass blank. It is a proprietary of a German company. You need and almost a 8 by 8 meter blank. You may be thinking, what is there, 8 by 8 meter, but the glass has to be almost a 1 feet thick. And it can get cracked when it's cooled. So it has to be cooled over a period of 8 months. And because every day it is cooled by 0.1 degree at that sort of thing. And after 8 months, you have to find out by local audio and X-ray that which are the not fractured, such a almost a 2 meter by 2 meter, you have to find out. And that you have to cut with a glass cutter. That is by a high-speed jet, water jet. And that has to be taken, and the machining for a 24 hours operation, it will take 1 year. That means obviously to place an order, selecting the party and everything, it will go another 6 months to 1 year. So in total, to getting a 𝗖𝗟𝗨𝗕 mirror itself will cost the ISRO almost 3 years. So I said, what is the alternative? They said, no alternative. I tried to give advice to them. They said, sir, you are from microwave. You dealt with wavelengths of centimeters to meters. We are experts in dealing with wavelengths of a few hundred nanometer. So we are poles apart. The director and his colleagues in the specialists, they are poles apart, or meters and nanometers apart. And I said, you look at a mobile telephone. What camera it has? They said, sir, mobile is a different, it's a cheap technology. I said, it has only pinhole camera. And the pinhole camera has a poorest resolution. And the pinhole camera, when you project it, they are actually sampled with a CMOS detector at a high sampling rate. They are very closely spaced sample then, and from that mathematical algorithm with a super resolution, and finds out the best possible resolution. So the one which has which has a best resolution has actually best software. They don't have a best camera. That is the beauty. I said that they figured it out. Why build such a big mirror? You make it 250 millimeter, almost a 1/6 of the size of the mirror, and you don't need zero door. And the only thing, you sample it at a very close place. And after all, the director says everybody follows up, because ISRO is still a straight-jacketed, not a fully freewheeling scientific organization. We're still straight-jacketed, and the stick works sometimes more than the brain. And they built a camera with a 250 millimeter reflector, and when its size is so small, you don't need a zero-door glass. You can manufacture from aluminum, which takes a 1 week of machining. And we knew this resolution would be 250 to 300 meters. But we put detectors of a high-density detectors, so that the same pixel is sampled at a 30 meter apart. And lo and behold, that actually ISRO doesn't have to make the 𝗖𝗟𝗨𝗕 of such a mammoth size. They can make cameras of a fraction of the cost of a normal 𝗖𝗟𝗨𝗕 camera, and they can put on a small satellite because it is just. And we have proven it in the GSAT-29. You will be surprised. A very coarse result image, a super result to very fine. In fact, we have tracked one PSLV launch. It is still operating, and it's a big change in technology. And to look at, there was a technology available in a domain called a mobile camera, and and our thought process of a technology is a brute force, very big one. And somebody of the experts, for some reason or other, they do not respect each other's technology. They think mobile camera means, it is cheap, it cannot go to space. And there needed a people like me, who are slightly unconventional, who is none of their fraternity, to tell them that they can do it in a simple way. And ISRO could save, I think, hundreds of crores in the making such a 𝗖𝗟𝗨𝗕 camera. And I left, if ISRO wants, they can put such cameras, many more, instead of on a satellite, 1/4 of the inside satellite size, weight, and make 4 such satellites launch, and 4 such satellites can actually image all the corners of Earth on a real-time basis and relay you every activity happening on ground, like a missile launch or something catastrophe is building up. So I give you these very, very small examples. The examples are so small and so easy. I didn't need a slide. I think I could explain it to you people. And it means that we must be able to think in a simpler fashion to build a complicated satellite. And it is our experience in ISRO. All the big failures had finally root not in hardware, but in the engineers taking care of very small things, and most of them are actually the college level or a school level physics. Thank you. I am ready for all the questionnaires from all of you.
Sharon, please proceed with the question and answer session.
Okay, sir. So I would like to check with Navneet whether Charu is here. Navneet?
Charu is here, I guess.
Okay. Charu, can you please go ahead with the question and answer session? Charat? Sorry, I think Charu has some network issues.
Hello, sir.
Oh, okay, sir.
Hello,
Sir, Adil, I'll be back to you. Thank you, sir. Thank you for your exciting introduction for our discussion and share your experiences with us. It was very delightful for all of us, all students of UL Space Club, to listen from you. And we have a bunch of questions and prepared and to ask with you. And there are many other students who are out of UL Space Club came for this session to interact with you. So I would request all students to raise their hands. If you want to ask a question with our speaker, you can raise your hands. Our coordinators will select you from the list. And first of all, Adil has already raised his voice. So I would like to welcome Adil Prajesh. He is a 6th standard student who is a prodigy of UL Space Club. I would like to request Adil to ask his question.
Hello, sir.
Yes, tell me.
I have a doubt.
Yes, tell me.
Please imagine a black hole coming to Earth to swallow Earth. It will become by 10, 20, or 30 years. What we can do?
I'll tell you, the black hole which will swallow Earth, it will be of the size of a marble. And you cannot do anything. It is the Earth will be swallowed by the black hole.
I think we can escape from that.
No, we cannot escape from that. But the chances are very rare, because people are talking of black holes, but they are always at the center of the galaxy. So they are not at the periphery, and those which are near the black holes, they will be continuously getting absorbed. Fortunately, we are away from the galaxy, supermassive galaxy at the center of Milky Way.
Okay, sir. My next doubt is we can make gravity on moon.
No, we cannot make gravity on moon, because we cannot change the gravity, because the gravity is always associated with the mass of that body, because a human being cannot change the mass of the body. But obviously, we can move in an accelerated speed away from it and all. Then our apparent gravity will be, we can make it 0 or high. It's like, our that human astronauts who fly in the satellites in the circular in an orbit, they experience a losslessness. You see them floating inside. So that sort of losslessness will come, but this is a pure physics. You have to move in a particular speed at a particular orbit. Then only you will have it. But if you start approaching towards Earth, when the astronauts land, it gets into so much gravity, they get almost a stress of 5 to 6 times Earth's gravity. So this sort of thing happens. Sorry, they get almost a less gravity, as if they're trying to float away all this. This sort of thing can happen.
Okay, sir, I have a doubt.
Thank you, Adil. We have to cut short the questions because we have plenty of students who are waiting to interact with our speaker. So you have already asked 2 questions. Sorry for this time. You will get another opportunity for interacting with him. So I would like to request other students also. I will call them by the name in the as they raise their hands. Between sorry sir, sorry for a little bit deviation from the desired topic. Sorry for that.
No issue.
Okay, sir.
I am perfectly okay if I am proven police.
Okay, sir. Thank you, sir. So I would like to request Ashira Sia for asking a question.
Good evening, sir. Am I audible?
Good evening.
Okay, thanks. So I am Ashira Zia, a high school student from 𝗪𝗏𝗪𝗏 Higher Secondary School. So I'm really happy to have such a great opportunity to interact with such a great personality like you. So can I ask my question?
Yes, you ask freely.
So my question is, I would like to ask that there is a lot of space junks now in our space that they've been thrown in last years. So I don't know it is currently problem or no, but it will definitely affect our satellites in coming years. So what is the solution for that? I'd like to know how is the possibilities for that. How will us overcome that?
See, the space junks is going to increase. However precaution you do, because it's a human nature to create junk. So even if we scientists will create junk, but the good thing is that you can see it from ground and then change the satellite's orbits. That is one. Nowadays, there's a lot of 5G and the 6G communication satellites will come up. There will be thousands of satellites orbiting. They simply, till today, whatever human civilization has launched satellites, there will be tens and hundreds of multiple satellites are going to be launched in next 1 or 2 years to give you 5G, 6G communication services. And there is also chance of pollution. But today, as and when our problems increase, we have also increased our understanding and technology. Today, they use AI and local measurements to instantly change the orbit. And this is what will be the future. You no longer need to observe from ground, but you can observe from the cameras or the sensors on board the traffic around and then readjust your path. It is just like, you navigate yourself through the crowded Bangalore paths or the Trivandrum paths and all those things. Because you observe all the people around and you change your course without colliding with anybody. And tomorrow, this sort of intelligence will be built in the satellites to avoid collision with the junk objects. And also, even with all these junks and all, it is still the space is still a vacant space. But we are changing the technologies. There is a newer way they are doing it. I'll tell you one thing. There's one good thing about it. They say because of this 5G satellites, that our remote sensing satellites will not have to have a satellite data transmitter. They can use an onboard Wi-Fi to the 5G satellites all the way to ground. They suddenly will see that all the satellite ground stations and all, they will become obsolete. They will no longer be there. I am expecting in another 5 years, all data transmitter would be through a Wi-Fi from the satellite to the ground, especially those low Earth orbiting satellites.
Okay, thank you, sir.
Thank you, Ashra. Ashra, could you please tell that which standard and which institution you are coming from?
I'm in 9th standard from RHSS 𝗦𝗣𝗭𝗛𝗞𝗢𝗏.
Okay, Ashra. Thank you for asking a question. And next, I would like to move on to Drishya.
Good evening, sir.
Good evening.
Please introduce your name. Please introduce
Sir, I'm
yourself with your class and
12th
institution.
science stream student, belongs to 𝗪𝗏𝗪𝗏 Higher Secondary School. Sorry, can you hear me?
Yes, I'm able to hear it.
Hello, sir.
Tell me.
Sir, could you please explain what are the major challenges in designing spacecraft for long-duration human space mission beyond the moon, and how can we face that?
See, beyond the moon, the big challenges are that the human beings themselves. Because human being without a society, without a company, have to survive. So that is one. Second is that can you carry a food supply for years of travel? Because those with the Earth orbiting stations, you can send the food supplies and water supplies in regular intervals. But then we have to think of alternately generating food supplies there. And you may carry probably food for 1 year, 2 years. I don't know, in future, will there be a technology that a food can be generated instead of planned by some machines? I don't know. I cannot just predict those situations. But definitely these two issues are there. And the second one, the way the hologram and the AI is advancing, it may not be worth to send a human being. It's like, it's something, we may hologram send some, information like a human being or a robot who will reconstruct. Who knows that tomorrow's robots will be like human being? And we can reconstruct, and we do not know that it can come up that a robot can be transferred through an information channel and it will reconstruct itself, or it will become another hologram which will be operating through here from Earth. We don't know, and we'll be seeing through that hologram or through the AI what you can say. That they say it is very difficult to predict the future, I must say, because the day I joined ISRO, I could never predict the days of mobile phone. So what I could not predict, even my ISRO life, being a space scientist, I don't know how can I predict. The science is moving in an extremely breakneck speed. And I will not be surprised, tomorrow an artificial intelligent people who doesn't need a feed, but who has all the feelings of human being, will be invading other or multiplying in other satellites without oxygen or with oxygen, with nitrogen or any other. I don't know. Things can happen. I just cannot predict.
Thank you,
So
sir.
does that satisfy you?
Yes, sir. Thank you, sir. And I have
Thank
one
you,
more
sir. Thank you.
question.
Okay.
Can we ever achieve interstellar travel, and what technologies might be required to make it a reality?
I believe it will not be human being. It will be something like a humanoid robots, which will not feel, isolation, which will can replicate itself in another place, which will not need a food, or it may food in a different form. It need not be gajar ka halwa or rice or fish. It may be some nuclear fuel, maybe a food for that. So such, humanoids have a greater chance of having interstellar travel than the human beings. And it is always a mystery, how the life came on Earth. Whether we are also born out of some other intelligent animal or not, I don't know, from some other place.
Okay, sir. Thank you so much.
Thank you, sir. Thank you, Drishya. Next, I would like to request Renu for asking a question. Renu Fatima. Please introduce yourself and you can ask your question.
Renu, tell me.
I think Renu has left out the meeting. So I would like to request Renu.
No, Renu is there, but her mic is off. Renu, your mic is off.
Hello.
Okay.
Yes.
Sir, my name is Renu Fatima and I belongs to 𝗓𝗏 Secondary School. Sir, I have a question that how do space stations provide life support?
Yes. Now, space station they have a oxygen generation facilities there. From water, whatever you breathe, whatever you take it out, this water is recycled to generate oxygen and also again to generate water. And also they have a regular supply of all the items they need for living, like the dresses, food, or even the body excreta to taken out. They have a regular supply is done from the ground. So it is supported by regular supplies, and some cases it is regenerated there. Or recycled.
Sir, I have one more question.
Yes.
Can I?
Yes,
How do satellites stay in orbit?
Oh, that is a Newton's law. See, if your velocity is such, that your centrifugal force is equal to the gravitational attraction force, then you experience a weightlessness and you move in a circular orbit. And obviously from Einsteinian gravitation, it is a slightly different experience. That is because of Earth, the gravitational field or the Higgs field is disturbed and you move in a path along the disturbed side where you'll have the minimum gravitational energy.
Thank you, sir.
Thank you, sir. Thank you, Renu. Now let's move on to the next person, Rajalakshmi. Please introduce yourself and ask your question.
Good afternoon, sir. My name is Rajalakshmi Kilji. I belongs to 𝗓𝗏 Secondary School, 12th standard. I had a doubt, sir. How can things explode and generate heat even if there is no air in space?
This, can you repeat it?
Okay, sir. How can things explode and generate heat even if there is no air in space?
How can they generate? Obviously, they do not breathe, but they always generate heat. Because any activity you do or any work you do, finally it gets converted to heat. In fact, all sorts of energy or work is actually heat. And while we convert a heat energy to a work, we also generate another heat energy. It's a thermodynamics second equation. Second law of thermodynamics.
Okay, sir. Thank you.
Thank you, Rajalakshmi. Thank you, sir. Thank you for answering our question. So next is Ganga S. Ganga, please introduce yourself and ask your question.
Hello. Hi, good evening, sir.
Good evening. Good evening.
So my name is Ganga S. I'm a 12th standard student of Pen High Secondary School. Sir, I had a... Can I?
Yes, yes.
Sir, where is the edge of the space is located?
Where is the?
Edge of the space is located.
Oh, it's really difficult to define because space is expanding. And you know, there was a recent James Webb discoveries are there. It shows a constellations which should not have been there. So this is indicating there may not be one universe, there may be multiple universes. So this sort of things are, nowadays I am reading it, I am also not able to understand fully, but it's very difficult to say where is the edge of space. But one thing we know that the Big Bang occurred at 13.8 billion years ago. So if at all, in at least in one direction, it can be at 13.8 billion light years away. Another direction, it is generally considered as a bell shape. It goes on expanding as it time progresses. It goes on expanding. But nobody has could find out an instrument to see what is the edge. Only mathematically they have a certain ideas of the universe and its content. But we're still building newer and newer instruments to see the space much further and further.
Okay, thank you, sir. I had one more doubt. Can I?
Yeah, yes.
Does a spaceship stop if the fuel runs out?
Pardon?
Does a spaceship stop if the fuel runs out?
No, it doesn't stop. What happens? See that Earth's atmosphere, we always tell it is up to 30 kilometers to 100 kilometers. But even, that up to 500 kilometers, there are also oxygen ions. And there are also a friction of the solar photons itself exert a pressure. If fuels let out, because of this, the very, very thin layer of oxygen at that height, atmosphere is there, but a very low pressure. And also the solar pressure and the solar wind pressure. With all this, it will start getting friction and its velocity will reduce. As it reduces, its height will also reduce. And ultimately, sometime in future, they will collide with the Earth or burn in our atmosphere. Sometimes it takes 1 year, sometimes it takes tens of years.
Okay, thank you very much, sir.
Thank you, sir. So I would like to request next student to ask the question. Before that, I would like to request all students to ask one question because we have around 20 students waiting to ask the questions. So let them ask the question. Let everybody ask the question. I request every student to ask only one question. So I would like to welcome 𝗦𝗣𝗔𝗖𝗘 to ask his question.
Hello, sir. Am I audible?
Yes, yes.
Hello, good evening, sir.
Good evening.
Belongs to 𝗪𝗏 High Secondary School. I'm a 12th standard student. I have a doubt.
Tell me.
Sir, in the nearest future, we want to shift to another planet after the end of Earth or Sun. So scientists have researched for an engine which do not use any fuel. So they introduced EM drive. Is it possible?
No, what drive it told?
EM drive.
Yes, you see that doing any work, you need a energy. Now this energy can be electromagnetic energy also can be there. Yes, there is a, see that at one time nobody could believe that the solar wind pressure can be used as a driving. Yes, it is driving. So EM drives is a possibility in future. But I have to generate the EM from some other energy source.
Okay, thank you, sir.
Thank you, sir. Thank you, Ivan. I would like to request Jobin Krishna to introduce himself and ask his question.
Good evening, sir.
Yes, tell me. Good evening.
So I'm Jobin Krishna from 𝗪𝗏. I'm a 12th standard student. So my doubt is, we have heard that the universe is expanding. It's a dot on a balloon. Does this mean that the distance between Earth and Sun or Earth and Moon is increasing? Can you please explain the expansion?
No. Actually, as per Newton's laws, that the Earth and Sun, the distance will not increase. The Earth and Moon will not increase or decrease. But as per Einstein's laws, they will gradually reduce and one day they will collide. So there is a truth in it. They will collide one day, but only the reduction rate is very, very slow.
Thank you, sir. Thank you so much.
Thank you, Jobin. Thank you, sir. So next I invite Anna to ask a question and first of all introduce yourself.
Good evening, sir. I'm
Good
Anna
evening.
Kalana. I'm Anna Kalana from 𝗪𝗏 High Secondary School. I'm a +2 science student. So my question is, what are the current efforts to search for extraterrestrial intelligence and what are the prospects of finding another intelligent life beyond Earth?
You see, on Earth, the life evolved. Many people say it is a God who has made it lives. But if you ask me, it is the thermodynamics second law where the entropy in a bizarre way got converted into life form, and they took the most stable and the strong element carbon as the source to make the benzene type of ring, and from that basis we built that more and more complex molecules were built, and then the life has formed. Now, so the most likelihood of a life should have a carbon in the ring. It could have been also silicon. They have also the similar 4 valence free bonds, but they are far away, so the valence bond strengths are weaker, so that their life will not stay longer. So they may decay fast. So in future, today, but this is only one way the life has formed. But you don't know that how the entropy dies has threw away the dies in a life in another place in another way. Just like, we are building robots. These are also gradually taking a life form. But they can operate in a high temperature. They may not need oxygen to survive and many other issues. So who knows that today's robots will become tomorrow's life form? You don't know them. because we don't know what will happen in future. We don't know in another universe whether the life is there or life is the same like Earth's life. That also may not be the same possibility. The life may have a different appearance in another place. Second is that there is two things, the life and consciousness. Consciousness is an abstract, it has no mathematical representation till today. That okay, the life we can explain in terms of second law of thermodynamics, that there is a possibility that entropy can get rearranged into another form of atoms to make a life possible. But we have no idea what is this consciousness we have. We have a life, at the same time we have a logic, we have a morality, we have a responsibility, and we have many other feelings which is actually comes from consciousness. And those cannot be explained by any of the laws of physics or the laws of life. So it's difficult to say. And I will not discount the existence of life in any other form in another galaxy or another star. Because the absence of proof is never a proof of absence. So I will conclude that way only.
Yes, sir.
Sir, I would like to request the next student, Harinanda, to ask a question.
Good evening, sir.
Good evening.
Sir, I am Harinanda, studying in 12th standard in 𝗓𝗏𝗏 Higher Secondary School. Sir, we all heard about some serious facts about space. Dark matter is one of that. So, can you please explain what is dark matter and dark energy?
Oh, yes. You see, there is the Hubble's law explains the way that the galaxies will spiral. And if you apply this Hubble's law, you can find there is a discrepancy. The Hubble's the velocity of the spiral, the way it is expanding in spiral, and the total mass of the galaxy. And this discrepancy can only be explained. There is another mass which is not visible through our observation systems. And because it is not observation systems, it is not observable, so that unusual mass, which is not observable in terms of material or gravitation, but so they are called dark mass and the dark energy. So this dark matter is a mathematical substitution for describing the anomaly of the expansion of the galaxies with the speed and from their mass content. So we have really don't answer till today. Some people are still telling nowadays that maybe the dark matter doesn't exist at all. The Hubble's law may be erroneous, and many other explanations are there. But just because we are not able to observe, that doesn't mean that things don't exist.
So, thank you, sir. So, next question, I would like to request Devashree to ask a question.
Good afternoon, sir. Am I audible?
Devashree, slightly louder.
Am I audible now?
I am not able to hear you.
Sir, now?
Now okay, slightly.
Okay, my question is that what happens when the control of a spaceship is
Devashree,
lost?
first of all, kindly introduce yourself and your institution.
Okay, I'm Devashree from 𝗬𝗪𝗏 Higher Secondary School and I'm studying in 12th standard.
Yes.
And my question is that what happens when the control of spaceship from Earth is lost?
Oh. Obviously, the space and control is lost, then it will still orbit. It still orbit because it's a Newton's law in action. But because of the loss of control, there is a periodic maneuver of its orbit manipulation, orbit raising, or orbit maintenance, or attitude control, so that its antenna starts looking at the Earth and communicate. So they may get lost over time. And it may become one day, or it can become maybe a month or a year. But ultimately, we'll lose it. And because there is no command, and it will start losing its energy because of friction with a atmospheric, the very thin atmosphere there, though it may be 10⁻⁹ bar and all, or it may be because of the solar pressure or the solar wind, and it will start decay its orbit. Finally, it will lose its height and fall on the Earth, or get burnt in the atmosphere. I hope I satisfied you.
Okay, thank you, sir.
So, thank you, Devashree. Thank you, sir. So, next I would like to welcome Shravana Kumar to ask a question.
Good evening, sir.
Yes.
My name is Shravana and I'm studying in 12th standard at 𝗬𝗪𝗏 Higher Secondary School. My question is this. In earlier days, there is a controversy that we can see the Great Wall of China from the moon. Later, it changed, but still there is a confusion about this topic among some people. So can you please tell me the real fact behind this?
No. See, the Great Wall of China can be seen from top. And also you will see from the space that our Rajasthan Kumbhalgarh fort, it is near Udaipur. You will see this fort also has a big wall like a Chinese wall, but not that long. So, and today's satellites are very, very high resolution, so you will be able to see. Unless somebody destroys the Chinese wall, then obviously it cannot be seen.
Okay, sir. Thank you.
So, thank you, Shravana. So, next I would like to welcome Arjun to ask his question.
Hello, good evening, sir. I am Arjun C. belongs to 𝗬𝗪𝗏 Higher Secondary School in 12th standard. My question is that, do you believe in the idea of Elon Musk mission to Mars? Is it possible?
You see, no idea cannot be thrown away, howsoever wild it may be, as long as it is possible by the laws of physics. So, it may be possible, and I do not throw away that data. In fact, at one time, nobody used to believe that a Columbus can reach India, but he finally found United States of America and the whole civilization and whole history, and it changed over things. At one time, nobody believed. So, as long as you follow the laws of nature and laws of physics and chemistry and all, you can achieve anything. But it may not be the today's technology, it may be tomorrow's technology. Who knows, that technology will be something different tomorrow.
Okay, sir. Thank you.
Thank you, sir. In between, I just lost my network connection. That's the reason between the delay. So next, I would like to ask some UL Space Club members to ask the question, who have already prepared their question, and I will back to the students of 𝗓𝗏𝗏 Higher Secondary School after that. So I would like to request 𝗓𝗏𝗏 to take over with this question. 𝗓𝗏𝗏.
Hello, am I audible?
Yes.
Okay, sir. So, sir, my question is, so I am 𝗓𝗏𝗏𝗏. I am from 𝗓𝗏𝗏𝗏, Calicut, a third year mechanical engineering student. So, sir, my question is, in our India, especially in our educational system, if we are considering bachelor's degree, there are very less colleges which offer courses on aerospace, astrophysics in that field. Only some IITs and IAST only have. Sir, I thinking there are lot of curious students who are into this space field, but is this educational system is restricting us to get in that field and do more?
The specialized courses are always better. But you know, what is aerospace? It is also based on physics, electronics, chemistry, and all those things. And in fact, we have not ourselves never gone into aerospace course. We have also become aerospace scientists. People call us aerospace scientists. So a specialized course, you know, and many of the courses are structured depending upon the demand in the market and the funding availability for the university. Every college may not be equipped to hire those sort of experts to teach those subjects because the number of experts are also low. But today, the more and more awareness is coming and more colleges are introducing, and the student demand also is increasing. So I think these are the issues there. But I don't know how I can solve it because it's something more dealing with the economics, interest, availability of expertise, and availability of knowledge.
Okay, thank you, sir.
And for your information, you know, Elon Musk was a graduate in physics only. He's not from aerospace college.
Thank you, sir.
Thank you, sir. Thank you for answering his question. Sir, I was hearing like talking about aperture radar and some other techniques that you were using and all that things. Today, I was just checking about what are the aperture satellite altimetric systems, including synthetic aperture radars and some other techniques that are used for satellite altimetry, for mapping and monitoring many other things on the Earth's surface. So, know about asymmetric aperture radar. So, as I realized, it is one of the most advanced technology among synthetic aperture radar systems. So, is there any other systems or other technique that are much more better than interferometric systems? What are the recent advancements in interferometric system?
Okay. You see, if you want to see Earth, any picture from Earth from space, you have to encounter two issues. One is that the Earth's atmosphere. So, Earth's atmosphere is transparent to particular light bands, except when there is a cloud or a dust or any other thing. So obviously, when it is a cloud, you do not see the ground below. That's natural. And the other is if it is night, because our light comes from the sun. If sun is not there, we do not scatter light. So that also is not possible to see from in the absence of light. So that is one thing. So optical has a limitations that they do not need, they cannot image all the time. Second is that you can find altitude by lidars. but then you need a very high power leaders, and you have to have faced the same problem of Earth atmosphere. If it is raining, the leader will not work. But and you need a tremendous amount of power to operate. In fact, there is a leader mission is being planned by ESA, an experimental mission from an altitude. So another thing, the synthetic aperture radar, apart from technology, is one aspect of the thing. It's a complex technology. But other is that it is in microwave. And the microwave, the atmosphere is transparent to the microwave. And because it sends a finite power and transparent, the signature is independent of the time of day and season. Like if I look at the camera, at winter I look at a different, in summer it will look different. The same tree, it will look differently green in the daytime than in the afternoon time because of the light spectra itself is changing. So these are the things. So there is a seasonal variation. So those variations will not be there, whatever you see the signature from radar. Second is that the radar, interacts with materials within an almost a few centimeters to few meters of depth. But an optical camera, they see only the top 2 to 3 micron height. They do not interact below that. So this puts you the radars in a much more significant position. There are another type of measurement is there. It's called the radiometer. Now, they say black body radiation from the ground. That can be also measured in different frequency bands in microwave and all. They also give you indirect reference in the measurement. So there are techniques. So some techniques are good at a certain condition. Some techniques are good in a certain other condition. If you want to see it in India, then synthetic aperture radar is a good one. But if you want to see the Saudi Arabia and Sahara, then the optical cameras are the cheapest solutions. So these are the different solutions for different things we get.
Thank you, sir. And about some other research opportunities other than satellites. ISRO was mainly announcing an opportunity for atmospheric studies. As we all know, 𝗪𝗪𝗏 rocket launching station is launching many sounding rockets for atmospheric studies, upper atmospheric studies. Yes. Of atmosphere. So we have heard about that one particular topic that struck in the minds of UL Space Club student coordinators. We were trying to do some studies on that, which was meteor smoke particle studies. To study and detect and study the meteor smoke particles. So there were much more other research avenues on this upper atmospheric studies. So is that possible to conduct this kind of upper atmospheric studies using satellite mission itself? Is it or is it necessary to do it with a sounding rocket payload? Yes. Especially I am asking about meteor smoke particle detection.
So there is no single technology sufficient. In fact, the whole space has come from actually atmospheric studies. The whole radar concept has come from atmospheric studies. So the atmospheric studies is one of the most primitive one. But there is a phenomenon. If I see from top, the surface, the radiation coming from ground will get attenuated. And I can see from bottom, from surface to the top, I can see differently. I can see the rain clouds better through ground radars than the space-based radar because I can have a continuous observation, but space-based radars will have an observation once in 30 days. So that may not be sufficient. You need a much more investment, having many more satellites. So there is a question of investment, there is a technology, and then there is a question of information I'll get about it. And let's say our whole Earth ecosystem is not exactly what you see on the surface. What is there in the atmosphere is governs this ecosystem equally strongly. So it is important that we observe both the elements, that the ocean, earth, the solid earth, the life form, like plantations, and the atmospheric conditions, they all together they decide how we live and how we enjoy this earth. And there will be different instrumentation for different things, and the different observations will require, some will require from space-based observation, some will require from ground-based observation, and some will require, the human sense. You will need the many things what radars cannot predict, the satellites cannot predict, the farmers in the village can predict, because they have another sense, which we cannot replace with another technology. So this is all. The human sense also matters. After all, humans themselves are the great sensors and great analyzers. So there are different things, and we must harness all the available knowledge and information to make a better and better understanding.
Thank you, sir. We will try to do that, sir. And before moving to the next question, I just want to mention that there are few student groups in UL Space Club are studying on this kind of payload works, and
limit the questions now. It will be quite long time for me.
Okay, sir. Okay, sure, sir. So I just want to mention that your support and guidance for this kind of project works in future also, sir. Now let me move on to Febin, and let's control question, and we wind up the question session. So Febin, ask your question.
I can take
another. Thanks, Varmita. Okay, sir, am I audible?
Yes.
Okay, hi sir, I'm Febin. I'm from 𝗦𝗣𝗭𝗛𝗏𝗛𝗏, Kerala. I have finished my 12th this year. And I am a member of the UL Space Club student panel. And when Schedule sir told us about that Tapan Misra sir is taking our next lecture, almost all of us were very much delighted. And now we get more to know about your startup, the CC startup. And almost in the remote sensing area, that's a very advanced remote sensing field, So the newest innovations which comes in mostly into these drones and that unmanned aerial vehicle sort of things, they are more focused on to that type of like artificial intelligence and robots. But I hopefully think that will be not a perfect replacement for these unmanned aerial systems, like SAR aperture radars or something like that. So what are the limitations for the drones and other unmanned aerial vehicle systems in the remote sensing area? Because the remote sensing is a wide field. It takes its big area to the archaeology and every sector in the sense, right?
See, it all comes down to economics. So I can vouch for you that of all the remote sensing technology, radar imaging is one of the very stable source of information. And it can give also the height of the terrain as well as the structural properties which no other sensor can give. The problem comes that technology is very costly. Like a satellite like reset, it will cost up to launch something like 800 to 1,000 crores. If I do it in an airborne system, it will cost each of the airborne SAR, it will cost somewhere between 350 to 500 crores. So, and if the system is costly, then their operation is also costly. And the business, that data becomes also very costly, because how I will tell you, they said today, there's a 1 meter resolution optical images. It costs approximately $30 per square kilometer in the international market. But for a radar image, the cost is approximately $250 to $260 per square kilometer for 1 meter resolution. Now, obviously, one of the best tools are not available to common people because the cost is very high. They are not available to common. So what I thought, let's say, how can I reduce the cost? One thing I realized, if the platform is reduced, the cost is reduction has been done, then one way I can reduce, because then and satellite cost approximately 400 crores. A aircraft cost almost between 100 to 300 crores. But if the drone cost only a few lakhs, 10 lakhs. And second is, if I make an hardware less reliable but cheaper, so I can replace it very easily if something goes wrong. That's a maintainable instead of a 100% reliable hardware. So that way that the SAR cost also can be brought down. And the best way is that because we do not need data of everything, because the interest may be different. The one who is looking, the bank which looks for the crop loans, agricultural loans, they will look for only those people who are taken loan from them, or that who have taken insurance from them. They don't want all of the earth to be imaged. So we thought that there is a place for low-cost imaging, very frequent imaging, and targeted imaging. So these things that to me, that drones appear to be the most appealing, because some people need an imaging every day. Say, if I do a crop insurance, I must have an imaging of our there every day. I monitor. And if I do monitor every day, I must operation do the costly. Because I am not interested in what is happening in Argentina. I am interested what is happening in only in some villages in Palghat, or some villages in Bardhaman in Kolkata, near Kolkata. So if my interest, because that the commercial interests are limited, so there is when a government of India looks at it, they look at it as synoptic way. The whole of India's growth rate, whole of India's crop production rate. But to a farmer, to a banker, his customer is the interest. His interest is not the whole of India. So those who want a specific projection, a specific interest, we thought there is a market which is untapped and we must bring it, and somebody has to take a risk, because obviously that if I want to produce 1,000 t-shirts per day, there is a ready market available. I need good designers and good salesmen. But I need a 100 square kilometer image per day at a cost of $6 per square kilometer. That fraction of even the optical images. But the market is not there. I may have a cheap solution. I have to create a market. So there comes an economics market there. And today another thing has changed. The intelligent drones have replaced all sophisticated weapons. The one can see the Ukraine war. That whole war's game has changed to drones. You don't need human being to lose lives. You can use some other inanimate object to lose themselves. So we thought that they will go for a market creation with a newer technology, there are problems, there are hardware problems, there are question of how to make things cheaper, and they changing a whole lot of psychology, and and obviously I don't have an access to that great specialist of ISRO, because they will cost me a lot. So I need to have a homegrown people who will not cost me a lot, but who can be grown. Because if I grow a new space scientist, that is more creditable to me than I only get some delta improvement or an established space scientist. So that with all this, I started this CC radar, and I am happy to find there are good fellows who funded me, and I do not believe in making big talks and all. But I may give lectures for my experience, but then what I can share with you, we have made a big change in ground penetrating radar, and which is being very sought after. In the world, nobody is having such ground penetrating radar of such depth and such a control in a software. That is nobody is having. Similarly, our drones will be a change, because if, though I am a scientist, I still believe it's something supernatural. There is something more than what we can understand. So I feel that the God's blessing is there. Maybe in this month we'll see a first drone-borne star images in the world coming out way from Calcutta. I am hoping, and it will be built by people who are no longer a big space scientist. It is the children like you, and every day I interact with them, and they teach me many new things. Every day I am reminded all my experiences in God throughout the day. Our children know better, and they can do better. And many people tell me, in the mobile age, our children has losing connection with the reality. I say this is wrong. Our children are actually becoming more connected to the reality. They are becoming more empathetic to society, and they are probably, if not equal, but at least more hardworking than our generation. I have a salute to the young people of India, and I bet my future and country's future on these young people.
Sir, I have a question to ask.
Yes, tell me.
So, sir, I am 𝗪𝗔𝗔𝗓 from 𝗪𝗪𝗔𝗓 Sainik School, and I am a cadet. I want to ask you one question that the rockets uses fire to lift the whole shuttle and launch it into space. And we know that space doesn't, in the space there is no oxygen. So how fire need oxygen to burn? So how will this rocket move forward?
No. It's not always it needs oxygen. There are other fuel combinations also can burn without oxygen. But they should have an oxygen content. They can be nitrous oxide or NO compounds. So this sort of compounds which are used, and I don't want to get into the details of this there, but each of these compounds has an oxygen inside in the structure, and they get released and they get burned.
Okay, sir, I have one more doubt.
Okay. After questions as the time. So can we? How many questions that we can take up now? How many more questions, sir?
It is already 2 hours.
Yes, sir. Okay. So
you can take one more question. I feel really sad that I am not able to.
Yes, sir. I will call one more student.
All the questions, because I have also too much limitations. And I have other obligations today also.
Yes, sir. That's okay, sir. So I would like to request Parthi to ask the last question. And from the Parthi, I just want to mention all other students who couldn't ask. You can send questions via email to us. We will connect with the speaker or some other experts to get your answers. So now you can send your question to the mail ID posted by Sayuj. You can send your questions to that mail ID, and you can ask the same questions if you are a member of our WhatsApp group. You can ask the questions in the WhatsApp group also. That's fine to ask it in the group. So now let's move on to the last question of today's question. Welcome, Parth. Ask your question.
Hi, sir.
Yes.
My name is Parthiv. I'm studying in 12th standard at 𝗪𝗪𝗏 Higher Secondary School. May I ask a question?
Yes, please go ahead.
Sir, I have heard about black holes, but I don't know what a singularity is. Can you please explain what's the singularity and what's inside it?
Singularity is a concept where no mass and no light can escape. So the black holes, is supposed to be the gravitational force is so much that no peaks, no light, no mass can escape, and it will gobble up. It's all the masses near it, another distance from it, call it an event horizon. But that's but of late recently has been proven even the black holes, have to follow the second law of thermodynamics. And they have to, even the black holes still radiate energy in the form of entropy, because that is an absolute law which is applicable to all the universe, because the universe is actually being run, and which determines that time is unidirectional, and the earth, the whole universe, the behavior is the second law of thermodynamics. And Stephen Hawking predicted that it will still though it gobbles up all the information and all the energy, it will still release a radiation called a Hawking's radiation. And it has been proven that yes, black hole do radiate energy in the form of Hawking's radiation, so that they also follow the second law of thermodynamics. So singularity is a mathematical concept, because any star beyond Chandrasekhar's limit, that is a 1.4 times the sun's mass, can eventually collapse because of its own gravity to a black hole, and it will drag all materials, lights from this event horizon. If it is a less than Chandrasekhar mass, it will become a neutron star, and the gaseous elements will convert it to high molecular metals, iron, carbon, and all those things, and they will undergo a big explosion in future. In fact, today we see that Earth today is actually a remnant of a supernova explosion of a neutron star. And that is why we get these heavy metals in Earth like iron, uranium, and all the heavy metals and periodic table, because we are born out of stars, we are born out of explosion of some supernova explosion, probably somewhere around 5 billion light years before. And from that, the star and present solar system has come. And from that, we are born, and we are, in figurative sense, we all are born out of stars. Thank you.
Thank you, Mr. Sir. It was a long, interesting session.
Thank you for responding.
Yes, students are with their curious questions, and thank you for supporting our students. And it's high time to continuously. Speaking is it's a hard work, it. Then it's we are stopping these questions, and the students can send these questions to our UL Space Club mail ID, and we can transfer and ask our scientists to get these answers. Okay, and I congratulate all the students by asking wonderful questions. Next, yes, 𝗪𝗏.
Sir, along with that, along with sending your questions, those who are not part of your Space Club and who are asked to give your questions today, we appreciate them, and they can be a part of WhatsApp and our activities. So they can also send their emails to the given mail address by mentioning questions, and they can also be a part of your Space Club community.
Okay. That's you do that. Why don't you post that link here? Then it's time for. Okay, sir. Thank you, sir. Thank you very much. And it's high time. And I invite 𝗚𝗟𝗨𝗕 sir. He's the former deputy director of ISRO. He's part of our university club to make a reflection and on today's talk. And Abhinand also get ready for that. Okay. 𝗚𝗟𝗨𝗕 sir, welcome.
Tapan Misra sir, good evening. Very good evening, sir. Yeah, I hope you remember me. Special project. And I fondly remember all those interactions we had, and then I'm at loss of words to link up again in this forum. Now I am at Calicut and I'm associated with Shajil and the 𝗚𝗍𝗫 sir in trying to spread the scientific temperament, etc., amidst the students. We have got a bunch of very, very curious and very interesting students here. So it's great. And first of all, let me thank you for spending almost 2 hours of your precious time clearing the doubts of, and more than clearing the doubts, inspiring these students. And of course, I need not tell again and again, for the benefit of the student community, let me say that sir is really one of the greatest doyens of space in India, having pioneered many cutting-edge technologies. And I can also say that in my own experience, when I interacted with him, he has come out with many, many innovative and cutting-edge technology development initiated at SAC Ahamedabad. We cannot explain more, but it has come very, very handy for the national security. And I always a big salute to you, sir, for that. So I don't want to mention more. So we will be in touch. Once again, it's a great pleasure to see you through this media. Shajil, over to you.
Okay, sir. Thank you, sir. 𝗚𝗟𝗨𝗕 sir is there. 𝗚𝗟𝗨𝗕 sir. And 𝗚𝗟𝗨𝗕 sir also. Sir, 𝗚𝗟𝗨𝗕 sir, please. 𝗚𝗟𝗨𝗕 sir.
Yeah. Good evening. It's a very long day for Tapan Misra ji. Tapan, of course, when you're talking about it, I fondly remember as 𝗚𝗟𝗨 mentioned, all the technology changes you brought it to ISRO. Okay. I know, as you mentioned very clearly, I also remember Leonardo da Vinci once mentioned, simplicity is the ultimate sophistication. Okay. And those people are bringing simplicity are supposed to be the very genius people. Very easy for intelligent fellows to make a very complex system. Only genius fellow can bring in simplicity into the system. Okay. We all know science asks question, why? And engineering says, why not? And technology says, how? All these three are blended properly in space technology. And probably you're one of those few people who are trying to blend all the three together. We know the effect of that in every field, but we can have about 50 years. I'm happy that you're also doing a startup with the startup company, doing something to the public, to the society, to the students, and all the way. I wish all the best for you. And it was very exciting to listen to students asking pointed questions in different areas, of course. Obviously, most of them are interested in astronomy and planetary science only. They ask questions, not in technology part of it. But still, they are very curious to know more and more things to do, what they can do and what they can do, the part of the system itself. I'm sure that people like Tapan will probably set up those systems wherein these students will find an opening for them to shine in the future days and bring India to the topmost developed nation status in the coming years. Thank you very much for giving me the opportunity. 2 hours, very long period. I think one of the longest sessions I've attended in the UL club. And Tapan being the very patient guy, he tried to answer all the questions. Thank you very much.
Thank you, 𝗚𝗟𝗨𝗕 sir. Your words are really motivating for the organizers also. Then you are continuously supporting this program. Then 𝗚𝗟𝗨𝗕 sir is also present from SAC. He is continuously, without any interruption, he is participating in the program. 𝗚𝗟𝗨𝗕 sir, please make a few comments.
Dr. Shivaram.
It is becoming very dark here because of the monsoon has arrived. So I switched on the lights.
Yeah, that's right. That's right. For you, it is in Kolkata, it will be slightly early.
Yes.
Then Shivaraman sir, are you available?
I think he's not. He's in Canada right now.
Oh, right side. Okay, sir. Okay, sir. But I could see. Then our PS Abhinand is also is a prodigy of UL Space Club and is a Nias Maya awardee, and now he's a student of Ramanjan School of Mathematics, Pondicherry University. Abhinand.
Good evening, sir. Good evening. Sir, my connectivity is little problematic, so I'm not switching on the camera. A warm good evening to all. We are delighted with such a long session. And just one thing I'm trying to mention is that one example all of we got from this talk, one single example from our speaker's life about the multidisciplinary and interdisciplinary aspect of the subjects in a highly focused world. From that example, we know how a simple, very simple idea in one subject can be solved very complicated problems in another subject. That's a very great, he had provided a great example of that, and many other very personal stories that will inspire us and that will give us creative ideas when we are going along our ways and how to handle problems, how to take responsibility. All this experience, what we shared is very, very great, and I'm not taking any more time. Thank you, sir. Thank you for this great experience.
Great. Thank you, Abhinand, and thank you, Tapan Misra sir, for coming to this forum and supporting us. And once we get a support from these kind of veterans, we think that we would be part of your Space Club and continuously support our students and our endeavors to motivate and grow them in the proper way. So thank you, sir. And it's high time to conclude these sessions. And before that, our founder and mentor,
No. Time is too much. Let us go to
Okay. Thank you, sir. Then I invite the student from 𝗓𝗏𝗏 Higher Secondary School for making the official vote of thanks from their bottom of heart. Welcome.
For that, I just want to say one thing.
Okay.
This is one of the most interacting sessions I have undertaken. I
Great,
am
sir.
really amazed at the length and breadth of the questions coming from students. And I try to answer the subjects more from a unified science principle than just a space science, because the science is indivisible. And science and nature are also indivisible. Anybody thinks that the science is devoid of nature, then we both are making very big, grave mistakes. So thank you all the students and all my seniors and all your members of Equal Education for giving me this opportunity. It is over to you, sir.
Okay, thank you, sir. And thank you for your kind words. Now, the approach, and we are
sir, can I interfere?
On tie with the science, with physics, biology, chemistry, and mathematics. Go on with that and passion. That's the message our speaker made here. And Varun, anything more to be said before we are going to the photo section session?
Yes. Yes, actually, it's one of the most important sessions that the Institute of Human Space Club webinar series. The coordination director a screenshot of this session. So I request all participants to switch the camera that we can take a screenshot of this webinar screen. So is that possible, sir? With your permission, sir?
Yes, please.
I am standing outside my home and I have to travel around 25 kilometers now. That's why I couldn't intervene. But the system was on with me. Okay, thank you. Take all of you, please.
Manish, please take care of the screenshot.
Okay. Like all of them has an important on.
Is it taken?
Well, not everyone has turned on.
Okay, don't worry.
All of you please try.
If any difficulty, don't try for that.
Let's close. It's already too late.
Okay, it's too late.
Yes,
Varun. Okay, why don't let's
Yes,
invite
sir.
the person who is in charge of
Yes,
this
sir.
vote of thanks. Okay.
Yes, after vote of thanks, you can access the quiz link. We'll post the quiz link at the time of vote of thanks. It will be open. You can access the quiz with that link.
Okay. Dear students, please try with the quiz also. That link will be posted here. Then I welcome the student who is interested to make this vote of thanks in this function. Welcome.
Good afternoon, sir. Can you hear me?
Yes.
Yes. Risha.
Good afternoon, everyone. It's my privilege to propose a vote of thanks and acknowledge the contribution of those who work to make this event possible. I'm Drishna J. On behalf of Peramabra Higher Secondary School, I would like to extend my heartfelt gratitude to each and every one of you for joining us today. First and foremost, I would like to express our deepest appreciation to our esteemed speaker, Dr. Tapan Misra sir. Their expertise, knowledge, and passion for the subject matter have been truly inspiring. Their valuable insights and thought-provoking ideas have undoubtedly left a lasting impact on all of us. We would also like to extend our gratitude to our coordinators. Mr. Varun, thank you so much for sharing this program. Shajil sir, the moderator of webinar, thank you so much. Thank you, Misra ma'am, for your advice, and thank you so much, Kutu sir, for the whole program. And thank you so much to Abhinand, Jaram sir, and Shivaraman sir, and also Akshay sir. And special thanks goes out to our dedicated organizing committee, UL Space Club, who motivates and trains the young children in space science, astronomy, space technology. Hope to have more opportunities to participate in your space and space camps and programs. Furthermore, we extend our appreciation to all the participants who actively engaged in the webinar. Your thought-provoking questions and insightful comments made this event really interactive and rewarding. Thank you once again for your time and your unwavering support. Thank you all. Thank you so much.
Thank you, Drishya. And all our program is used to streamed through our YouTube channel, UL Space Club. And it would be an evergreen repository for our students for the future reference also. Thank you, Tapan sir, for being with us this long time. Thank you. Be with us.
It's a pleasure.
I invite you to the UL webinar family. I like your permission to be added to that veterans group also. That's our pleasure to include them with the whole heart. Okay,
Thank you so much.
Thank you, Kutti sir.
Thank you, Vijay, thank you.
Saram, thank you very much.
Tapan sir, we extend a warm welcome to you to Calicut. Kindly visit us. We will be very happy to host you here.
Yes, I'll plan.
Yeah, please.
The only question is going to invite me to IIST, he told me.
Okay.
That time I will make.
Yeah, sure, sir.
Okay,
Thank you very much.
So nice of you. It has been a blessing for us. Your presence was a blessing for us today.
Thank you, sir. Thank you very much.
Thank you very much.
So I'll take off.
Okay, please. Thank you, sir.
Bye, sir. Thank you.
I kindly request the coordinators to stay back as Kutis has suggested. Others can leave now.
Shajil Mash, Varun, who else is there? Abhinand is there?
Yes, Sayuj is there, Abhinand is there, Navaneet.
Sayuj, Navaneet, Abhinand, please stay on.